So in this video, we'll look at the meaning of critical numbers and critical value for any given function f of x. And let me write down the definition here. So x is a critical number if f prime of x equals 0 or f prime of x is undefined. And that's basically the definition of critical numbers. And critical value is basically the evaluation of f of x at this point of critical numbers. So you need to find this, and x is a critical number. And before doing any calculation as an exercise to this topic, and we would like to briefly describe the meaning of critical numbers on the graph. Let's look at the first possibility, f prime equals 0, where x is a critical number. And please imagine what's happening when the f prime is 0. The fact is that when f prime is 0, it means the slope at that particular point is 0, which means if you look at the equation of tangent, like the current picture, right at this point, you see x naught. When you look at the tangent equation, I mean, you can imagine that you are traveling on this line, you're going upward before approaching the point x naught, and right at this moment, you are turning your direction from increasing to decreasing, right? I mean, you're going down after passing the point x naught, and right at the moment when you are at the top x naught, if you look at the tangent line, it is actually horizontal. And horizontal tangent line basically means f prime, which is the slope value for the tangent line at this point, is 0, right? So you see, this situation is what we call local maximum. And you can easily imagine if we have other scenarios where x is a critical number such that f prime is 0. So let's draw other pictures. If you look at the picture number 2 here, once again, right around the bottom here at this point, you can see that the tangent is horizontal. And once again, it basically means that the slope is 0 at this point. And once again, this point is a critical number. And for such situation, we call it local minimum. And let's imagine other scenarios where you can get a critical number such that the f prime is 0 next. So please look at the current picture. If you imagine that you're actually traveling along this line, you see, you actually keep going up all time. So, however, if you look at this particular point around here, right at this moment, you're actually traveling in the horizontal direction, right? And it means that if you draw the tangent line at this point, once again, it is a horizontal tangent, which implies that at this point, the f prime at x naught is 0, which is a critical number, obviously. It's a critical number because f prime now at this point is 0. And however, this point, we cannot call it a local minimum, local maximum, right? Because you see, local maximum, local minimum requires that you are changing direction at that particular point, like the pictures 1 and 2 we gave you before. However, in this picture, you keep increasing all the time. You are just at the moment x naught where right at that particular moment, you are traveling in a horizontal way. And this kind of point, we actually call it point of inflection. And we'll describe it in more details a bit later, not now. We can look at picture number 4, and 3 and 4 are quite similar in the sense that you're not changing your direction at all. If you travel from the left side to the right side in picture 4, you're actually going down all the time. But just at this particular moment, you're actually traveling in a horizontal direction at this particular moment. And same thing happens at this point. F prime is 0, so we can call it a critical number. And once again, at this point, we cannot call it local maximum, local minimum, because you're not changing the direction you're traveling. So once again, we call this point a point of inflection again. And these are basically the scenarios for the case where x is a critical number such that the f prime, the derivative at that particular point, is 0. So next, we'd like to look at the situation where f prime is undefined for the critical number x. And please think about the graphs that you can have at this point. So for example, please look at the current picture. You see right around this point, you're actually going up vertically. When you're going up vertically, it's actually a vertical tangent, right? And when the tangent is vertical, the slope is undefined. Because the slope is kind of, like numerically the same as non-zero divided by zero for the slope, because now the x coordinate is fixed. And the definition of slope is that you are taking the difference of y value of 2 points divided by the difference of x value of the 2 points. And because x never changed, so the slope is actually quite the same as undefined. I mean, in the sense that it is a non-zero divided by zero as a fraction. So anyway, this is one of the situations where you can get a vertical tangent, and right at this point, we also call it a critical number. And of course, there are other scenarios. You can look at the picture number 2. You see, right at this point, the tangent is vertical. And once again, it is a critical number for us. When the tangent is vertical, the slope is undefined. And these are quite common scenarios for you to have the critical number such that the f prime is undefined. And once again, in these two cases, we call these points of inflections. And let's think about if we can get other scenarios such that f prime is undefined. Let's look at this graph, y equals f of x. And you see at around this point, x naught, I hope you can see what's happening. When you try to approach this point from the left-hand side, like this, we know that you keep decreasing and you keep going downward, and right at this moment, it looks like the direction that you're traveling is going down, like this. However, on the other hand, if you leave point, you're actually going up suddenly without a continuous change of directions. So the change around this point is not continuous because when you pass through this point at that particular moment, the tangent is actually pointing upward because it looks like you are increasing all the time. So you see, in this kind of problem, we say that the derivative f prime is undefined because the tangent cannot be uniquely defined. Because you see now it looks like you actually have two different tangent lines, the red one and the green one. And obviously the green and the red are not the same. When the tangent line cannot be uniquely defined, it looks like you have two different possibilities of tangents, and there's no point to talk about the meaning of slope. I mean, because even the tangent is not unique, right? So in that case, f prime is undefined because you can't even write down just one single tangent. And these are basically the common scenarios for the case where f prime is undefined. So let's look at some calculation problem. So please look at the current problem, and just to remind you, to find the critical number x, you need to solve either one of these two equations. Either f prime is 0 or f prime is undefined. So let's look at the current example. Let's find the derivative first. The derivative of f now is the same as 8x plus 8. There's no chance you can get any point x where the polynomial is undefined, the value of the polynomial. And so we just need to solve f prime equals 0 now. 8 times x plus 8 equals 0. And you can solve this, and x is actually minus 1. And this is the only critical number for this problem. And in the case that if I'm asking you to find the critical value, critical value means you need to do the evaluation of the function f at the critical number. So you need to evaluate it, and 4 times minus 1 to the square plus 8 times minus 1 plus 1. And actually the answer is minus 3. So it is a critical value at the point x equals -1. And that's how we find the critical number and critical value. And just like the pictures I described a little bit earlier in this video, obviously, I mean, at this stage, you understand that this point is critical number, -1 is a critical number, and the critical value is -3. But we don't have any idea at this stage whether it is a point of inflection or it is a local minimum, local maximum. And these kind of problems we'll try to see in the upcoming videos. And for now, you just need to find the critical numbers and critical values. Let's look at the current problem. You're given a function f, and I'm going to ask you to find the critical numbers and critical values for this function. And same as before, we need the derivative f prime. And let's find the f prime first. So the derivative in this case is 6x squared plus 12x minus 48, right? And once again, for this function, there's no chance you can get f prime is undefined, no chance. So we can fix it to be 0, and let's solve it together. And I hope that you can do a quick factorization by picking the common factor 6 out. And now you can factorize the polynomial of degree 2 up here by using the factors x minus 2 times x plus 4. And it means x is equal to 2 or minus 4. And we have two critical numbers here. And let's do the evaluation at these 2 points for the function f of x. And f of 2, if you use calculator, is actually quite easy to see that f of 2 is actually minus 49. And similarly, for the second critical number, we can evaluate it for the function f of x at minus 4, and you will get that the value is actually 167. And these are the two critical values corresponding to the point 2 and minus 4. And in the next couple of videos, look at the topic in more details, like we'll try to find the maximum, minimum point of inflection, and etc. based on the critical numbers.